Hey guys, so I'm gonna be explaining how I solved Advent of Code Day number 5 and how I could have improved my solution. So guys, as you can see, we get the example right here, and we're supposed to essentially read each one of these things line by line. So you see in this notation x or y, and then it essentially means if 47 should be before 53, or should be printed before page 53. So each one of these numbers are pages. No, these are page ordering rules. And right here, guys, you can see we have a page, the page numbers, and each lines, guys, they're known as an update, right? So essentially, in order to solve this part 1 of this challenge, all we need to do is to find the updates. You can see I'm highlighting it right here, and essentially check to see if it follows these ordering rules. So my solution, guys, was to iterate through each one of these things, each one of these updates, and then for each value, meanwhile we're iterating, we check to see if it matches with the ordering rules, and if it matches, guys, then we know that this part is correct, and then we keep repeating that, guys. And if we find that one of the ordering rules is mismatched, or it doesn't follow the rule, then we essentially skip that list. But if all of the numbers follow the rules, then essentially we just we're just gonna store it. And then, guys, you can see it says we must find the middle page number from each of the correctly ordered lists that we found, and then we find the middle page number. And then we add up each one of those middle page numbers, and then we submit our answer right here. So guys, here is the code for my solution. Let's look at challenge 1. So as you can see, guys, I created a structure called list_array, and it essentially contains a data structure that we implemented in a previous video. It's essentially a dynamic array. So you can see here it is. It's just a dynamic array of integers. And we implement that basic data structure so it can make our lives a little easier when solving these challenges in C. And we define this structure, list underscore array, to be an array of lists. And then now, guys, we create a function to initialize the list, and then we create a function to append a list to the array. And here you can see we're doing malloc, realloc, and then we create a function to print out or array of lists in a visual manner. And then we create a function to destroy or give back the memory that we asked the operating system to give us back to the system. And then we free the list, and then we just reinitialize the list. So it just sets all those things to null. So if we wanted to resize the list, reuse the list again, then we could do that. So you can see right here, guys, we have a function called isRuleMatch, and it accepts a list of arrays, an array of lists, and it takes in two values, A and B. A and B represents these X and Y values based on our notation. So X is the first page number and Y is the second page number. And then, guys, we iterate through each of our rules, and we compare and check to see if each of our values, if the values at index 0 and index 1, so is equal to A and B respectively. Now let me go down right here to where we actually parse our puzzle input. So you can see we open up our file. We have three variables, X, Y, and Z. We have a list array of our rules and one for each of our updates, right? And then now, guys, we use fscanf to parse our file. So if we go into date5, you can see example.txt. So guys, you can see right here, so essentially, guys, we extract each page rule, page ordering rules using the notation thing. So we extract the first integer and the second integer. We place it in X and Y variables. Then we create a rule, and then we append those X and Y values, which are integers, to that rule, guys. Then we append that rule to our rules array that we have right here, which is an array of lists. Then we try to get the next character after we have parsed this thing. So after we have read like 4753, there is a new line character that comes after it. So we check to see if the next character is a new line, then we just call fgetcf, and we check to see if the character that comes after that new line is a digit. So this way, guys, we can parse each line without breaking this loop. And then if the next character that comes after the new line is a digit, then we unget that character, so we place it back onto the file stream to be read. And then, guys, we say we just print our rules that we have parsed. So you can see it right here. Let me just try to compile this thing for you guys. Alright, just for demonstration purposes, I'm going to change this to example.txt. And let's recompile our code. So you can say we have the page rules, guys. So we're essentially extracting the x and y like this. So you see x, y, so we can see we're parsing each line. So we see x, y, x, y, x, y. And it's essentially the same thing from our file called example.txt, guys. So we're getting xy, so that's 47 for x, and 53 for that. And you can see, guys, right now I can get rid of this for now. So 47, 53, and then 97, 97, you see? So that's essentially what we're doing, guys. Then for here, we are just reading these things. So we get 75 and 75. So we just read the updates, we parse the updates, and then time to actually show the solution. So we have a print total middle pages thing. Now before we actually do that, we need to find the correct updates. So the correct updates, we check if the update is correct, and let's look at this function. So we define a boolean is rule match, which takes in the rules, and it takes in two integers a and b, which is essentially these x and y things. And then we say if we iterate through each one of our rules, and if we find one of them at index 0, which matches A, and 1 at index 1 that matches B, then we return true. And then, guys, we say we have a function to validate now if an update is correct. So in here we iterate through our update dot length -1, since we don't want to go out of bounds of our array, and then we check to see if is rule match rules update dot array index I update dot array I +1, and if we do a bitwise not on that too. So let's say it returns true, then it's just gonna return false, since we're just checking each numbers one by one sequentially in our list or in our update. And then guys, we pass in the current element at the current index and the next element at the current index I +1. And then if it doesn't match, then we just return false. Otherwise we just return true. Then we say we define a function called find correct updates now, and it calls this function update is correct, and then it essentially appends each one of our updates that are correct into this correct updates list. And then guys, this print total thing actually calls this find correct updates function, and then it defines a variable called total middle pages, and then guys, it iterates through each one of the correct updates that we have found, and then it increments it by finding the middle element within the correct updates list, which is essentially the length of the number of elements in the current correct update divided by 2. And then we just print out the total number of middle pages. And then we get the answer, guys. You can look up here and you see we get 143 like in our example. And for the puzzle, guys, you can see we get 4662. We can try replacing example txt with puzzle txt, and we'll get the same answer. It's 4662. So then now guys, let's move on to part 2. That's challenge number 2 and how I solved it. So for challenge 2, I just reused the code from the previous challenge. That's challenge 1, and then I just modified it a bit. So here's how I did it. I modified the total middle pages function. I create an array called, I renamed this array from correct updates to incorrect updates. And then I said I renamed the find correct function also, in find incorrect updates function also, which accepts the rules and the updates. Then I said it essentially returns an array of the incorrect updates. So I utilize my isIncorrect function. IsCorrect function. which tells us if a particular update is correct or not. So I call this function, and then guys, you can see I call that function, I pass in the particular update, and then I essentially append that incorrect list to our incorrect updates array. And then guys, I create a function called correctUpdate, which essentially corrects the incorrect update and turns it into a correct version. So I essentially iterate through each one of the elements in that particular incorrect update, and I check if not, rule match, then I compare the current element with the other one, and if this function returns true guys, then I essentially swap the values. So let's say 75, we compare 75 with 97. It will try to search for it through this whole thing, and if it finds 75 with 97 and they are out of place, then it will swap them. Now, here is where I found that I made a mistake right here, guys, but it still solved the problem despite so if I run the code, you guys can see it still solved the problem. So I'm iterating through the array of lists 2 times. So this is like O of n time complexity. So here's how I could have optimized it a bit. Instead of doing this, I could just correct my correctUpdate function. And I could have said while not is correct, while not update is correct. So I call this function up here. Then I say rules incorrect update, dereference that pointer, and then I could just call this function, guys. So that would essentially reduce the time complexity a bit, and it would run faster, because if you look guys, when I run this, it kinda has a slight delay. Now, if I just call it like this, you will see that the code runs a little bit faster. You guys can see, almost instant. And that is how I solved the problem, guys. So you can see it prints the answer, and here I have submitted it, and I got my 2 stars. So thank you guys for watching, and I'll see you tomorrow for Advent of Code, day number 6. But wait, before I go guys, I want to talk about how I could have optimized it a bit more. So one way I could have optimized it a bit more is I could use a hash map. Now, I haven't implemented a hash map in C in order to solve this problem, so I just sticked with a more easier solution. But if you guys want me to implement a hash set, then you guys could let me know in the comments. So, thank you guys for watching, and I'll see you tomorrow for day 6.